In this video, we're going to think about how we can start adding more sophisticated behavior to programs that we want to write. Because now we've got the basic tools to write programs. We've got variables, we've got assignment statements, we've got expressions, if statements that allow us to make decisions, and loops that allow us to repeat operations. We've also got collections when we want to gather together multiple objects. And we've got the whole idea of wrapping definitions in classes, defining methods inside classes, and the ability to create multiple instances from those classes. So we've got a lot of basic programming tools. And at this stage, the main aim is to just expand our understanding of what the possibilities are, particularly by exploring the classes that other people have written and made available to us through libraries or packages of classes. And Java comes with an extensive library of classes that we can make good use of that will really speed our ability to write programs. And so this video is about learning to explore library classes, learning to read the documentation that's been provided by the people that have written classes. So in the Java class library, there are thousands of classes, and inevitably, there are therefore tens of thousands of methods, but there are many classes that will make life easier. And so we want to look at ways in which we can learn to explore the documentation, find out about new classes that exist, find out about the functionality that those classes provide us. Because using library classes is going to save us an enormous amount of time. We've already seen that using classes like ArrayList or LinkedList means that we can build quite sophisticated functionality without having to write everything from scratch for ourselves. Now, classes tend to be grouped together into what are called packages, and packages are also grouped together in what are called modules. It's a requirement really for competence in any Java programmer, or indeed in other programming languages as well, to know what exists in terms of libraries that are available. And indeed there are libraries that go beyond the standard ones that come with the Java Development Kit or the Java Software Development Kit. People are forever writing useful functionality and making it available in the form of library classes. And the great thing about those classes is that we can often use the functionality without having to necessarily understand exactly how it's provided. So this is a good example of abstraction in action. We don't need to understand the low-level implementation. We simply need to understand how we can gain access to the functionality via the classes and the methods that those libraries provide. And so we'll be exploring how to read documentation in order to get access to functionality through what's called the interface. In order to carry out our exploration, we're going to look at a textual interactive dialogue system. And this particular example is heavily based upon the ELIZA system that was written by Joseph Weizenbaum in the 1960s. And a really nice thing about this idea is that we can provide a semblance of intelligence or understanding by writing relatively simple code. Now, for all practical purposes, this wouldn't really stand up to intense scrutiny, but we can see some quite nice ideas. But the idea of writing an intelligent system is not the point of this exercise. The point of this exercise is, if I want to build something interesting, how do I find out what tools are available to me in order to write that? How can I tap into library functionality? So let's take a look at the interactive dialogue system that comes with the materials for the Objects First with BlueJ book. This is what we call the tech support system, and this is in fact the final version that we develop in chapter 6. So the functionality is complete, and I just want to illustrate the way that it works so that we can think about how we might build something like this. And what we'll do is we'll work our way from a prototype system through a couple of steps until we get to the point where it would be possible to implement this. And in the process, we'll explore quite a lot of the fundamental elements of how to access the API, the Java API, or the application programmer interface. I've already created an instance of the support system class, which is down here, and it has one method which is simply start. And when I call start, we get a greetings message from the Dogisoft technical support system. So the idea is that this program is providing an artificial intelligence interface to some kind of troubleshooting system. So the Dogisoft company markets some software and it provides this service to customers who might be having problems with their software. And it invites customers to type questions about any issues they might be facing and then seeks to give them some kind of plausible response to those questions. So let's try a simple problem that a user might have encountered. Maybe something like your program runs out of memory. I'm get a response which says, if you read the system requirements carefully, you'll see that the system memory requirements are 1.5 gigabytes. You really should upgrade your memory. Anything else you want to know? So we've got a response that seemingly has noticed the word memory in the input and is trying to give something that's related to what was in the user's input. So let's type another problem. Your program crashes under Windows. Well, it never crashes on our system. It must have something to do with your system. Tell me more about your configuration. So it's a Windows PC. This is a known bug to do with the Windows operating system. Please report it to Microsoft. There's nothing we can do about this. So there does seem to be some link between the responses that the program is providing and the customer's inquiries. And even though the system is not being terribly helpful, it's simply pushing the problem back on the customer, we can see that it's somehow recognizing something about the user's input and then responding accordingly. We finish running the program by typing the word bye, and it responds, nice talking to you, bye. So let's think about what problem it is that we're trying to solve, what the steps might be that are involved in solving that problem, and then some of the programming features that we might need in order to provide a programmed solution to that problem. So these are the core steps of the task. We want to be able to read some input from the user. We want to be able to identify individual words within the input in order to try and gain some understanding of what the user's problem is. We probably want to look for significant words, words like memory, crash, Windows, and so on. Things that might be indicative of what the problem is. And then we want to provide a response that's based on those significant words. And if we don't recognize any of the words in the input as being significant, then we want to provide a response that perhaps encourages the customer to provide a little bit more clarification, something like that. So those are the high-level tasks that we want to find program solutions for. And if we just move down the line a little bit and think about steps that the solution might require, then we need to be able to read the user's input. How do we do that? We want to split up the user's input into individual words. So we're going to take a relatively simple approach to that. We're going to separate elements of the input string around white space characters. So wherever there's a space, we'll take that as being an indicator of a break between words. Now we could make this more sophisticated. We could make sure that we look for punctuation and use that as a separator between words as well. But let's stick with spaces for the time being. Further sophistication could be added later once we've got a basic program working. We then have this idea that we want some associations between words that the user might type, memory, CPU, crash, and so on, and the kind of responses that we want the system to provide back to the user. So we want some kind of pairing between input words and output responses. And so we're going to be using the user's input to select a response from potentially amongst many potential responses. And then if we can't find a match between the user's input and keywords that we think the user might be typing, then we want to randomly generate some response that invites the customer to further clarify. And we want some kind of random generation of that, because we don't simply want the program to keep repeating, I don't understand, but we want to give the impression that there's possibly a human user that's reading the user's input and responding in an intelligent fashion. So we want a degree of randomness in the responses if we don't find some kind of match. So taking those pieces and thinking about how we might begin to build a solution, we're going to explore those first steps in a simplified version of the completed program. So here's a very simple version which on the outside does a similar job. It outputs a greeting message, invites us to type our question, your program crashes, but simply responds, that sounds interesting, tell me more. So it runs out of memory. That sounds interesting, tell me more. So in fact, this program is not able to process the user's input in any significant way or generate a significant response other than that sounds interesting, tell me more. But what we have is a framework for developing a more sophisticated solution. So let's look at the elements of that framework that we've developed so far. The overall problem has been broken down into three main elements. We have a class called input reader that's going to be responsible for reading the user's input. We have a class called responder that's going to be responsible for providing responses. And then we have a class called support system that's responsible for coordinating the activities of instances of the other two classes. So we can think of the support system as class as providing the main processing loop that requests user input, passes it to the responder, provides the user with their response, and so on. So let's look in detail at the current level of implementation within these three classes. So here's the responder class. It has no fields, so no persistent state. It has a single method, and all that method does is print a holding message to say, that sounds interesting, tell me more. So at the moment, we've just got a framework for coding up how we might actually respond to the user's input, but no more than that at the moment. The input reader class does have some functionality. It has a field of type scanner. What's a scanner? Well, a scanner is imported from the java.util package, and we could explore what a scanner is and what functionality it provides, but we're going to defer that. We're going to explore the API through a different class, but we just note that this is one of the classes that we've discovered through reading the documentation. We recognize that it provides us with the ability to read the user's input, and so we're making use of it as the simplest way of reading whatever it is that the user wants to type. And then there's a method called getInput, which prints a simple prompt and then reads a line from the user and returns that. So let's see how instances of the input reader and the responder are used by an instance of the support system class that provides the coordination between those elements. So here the support system has a field of type input reader and a field of type responder, and instances of those are created in the constructor. And then really the core of the processing that goes on within the system support instance is conducted within a loop. It's an iterative process. So following the printing of a welcome message, we've got an iteration that keeps on going until the Boolean finished variable is set to true. And on each iteration, we read the user's input. We look to see whether the user had typed the word by, and if they have, then we set the Boolean finished variable to be true. But otherwise, what we know is that the user has typed a question, and now we must formulate a response. So we ask the responder to formulate a response. And we'll look in a little bit more detail at this method in the context of the slides. So this is the main loop structure that we've just seen. It's a very common iteration pattern. It's the sort of while loop that you'll write many times where you've got some controlling condition that as long as that condition evaluates to true, then we want to iterate at least one more time, and we'll do something, and the doing something is likely to cause something to happen that will ultimately cause the condition to become false. So having done something, if the exit condition now applies, in other words, what we just did means that we no longer wish to iterate, then we're going to set the controlling variable to be true, so that next time we come around the loop, we'll leave the loop and carry on with whatever follows. Otherwise, we'll carry on doing the main reason for the iteration. So this is the pattern that we saw in the method in the support system, and the elements that we're carrying out inside the body of the loop are twofold. Firstly, we want to read some input from the user, and that's done via the reader instance. And then we want to generate a response and print the response. So in this particular version of the tech support system, we see that the responder does not actually receive the user's input. And that's why it's not able to do any kind of matching on significant words and providing contextualized responses. It's simply repeating the same phrase again and again and again for each response. But that's what we're going to be looking at and developing as we explore the functionality that's available to us through the Java API. So the exit condition is managed by comparing what the user has typed against the word by. And we're calling the method starts with on the string instance in the variable input. And the question is, where does starts with come from? How did we know that that particular method was available to us? And the answer is we can find out more by reading the documentation for the class to which the input variable belongs. So input was a variable of type string. In order to find out more about the starts with method, then we need to go and find the documentation for the string class and see what it says about the starts with method. Now, all of the documentation for the standard Java classes is freely available online, and there are different versions of the information depending upon the particular version of the Java environment that you happen to be using. So the documentation is provided in the form of an API, or Application Programmers Interface, and that provides descriptions for all of the classes in the class library. So let's take a look at that online version of the documentation. In the browser here, I've actually got two different versions of the API documentation. So this is the documentation for Standard Edition version 8. And this is the documentation for JDK version 11. It has slightly different format. So here we have a section that lists all of the packages available within the API. And then underneath it is all the names of all the classes that are available through the whole of the API. So organized alphabetically. And then over on the right hand side, we have the packages listed again. In this version over here, we have the documentation for a module called java.base, and that module again lists the packages that are available to us that we can explore. So the structure is slightly different, but the two versions of the documentation are providing us with essentially the same set of information. Now we want to know about the string class. We want to know in particular about the starts with method of the string class. The string class is defined in the java.lang package, so I can click on java.lang and then I can find the string class, which is here. And here we have the standard format for class descriptions within the API documentation. So all class documentation starts with a general overview of what the class is intended to do. You might also find some implementation information within there, because that can sometimes be useful to know about, although it's not essential in terms of using the class. And then a series of sections on any fields that might be publicly available from the class, any constructors that are available for creating instances of the class, and then usually the majority of the documentation is taken up by the list of methods that the class provides. So you can see that the string class provides a very large number of methods, and we're particularly interested in the starts with method. Now it turns out that there are actually two versions of the starts with method. We won't worry about the second one, we'll just focus on the first one. So if I click on the name of the method, then it takes me to a more detailed explanation of what the starts with method is all about. In particular, it tells me what parameters are expected, and it tells me what the method returns. So this description here says that the method tests if the string, and what it means is the string on which the method is being called, whether that string starts with the specified prefix that's passed as a parameter. So you'll remember that in the code that we looked at, we were interested in whether the input string started with the word by. And the starts with method says, I'll look at the first prefix length characters of the string on which the starts with method is called, and if they match, I'm going to return true. If they don't match, I'm going to return false. Now, because the method is called starts with, in fact, the string the method is called on could have many other characters following the text of the prefix and still return true. It's only interested in looking at the starting characters of the string. It's not interested in anything else, and we'll illustrate how that works in a moment. So this is the documentation for just one of the methods within the string class, but if we were to browse the page generally, we would find exactly the same structure of method descriptions. So series of parameters for this one, descriptions of the individual parameters, what the method returns, and then a discussion about what the method is trying to do. This just happens to be an arbitrary one. It's probably easier to look through the list of methods where there are summaries over on the right hand side to find out whether methods potentially will do what we want. So here's the method length, which returns the length of the string. It doesn't take any parameters and it returns an integer. So we can work out that that's the method we would call if we wanted to know how many characters there were in a string, for instance. There are some other methods that we'll see used in a moment. A method like toLowerCase converts all the characters in this string to lowercase. So we might have a camel case string, but we want a purely lowercase version. This would be the method that we would invoke on a string. Now notice that this method returns a string. So what the toLowerCase method does is it doesn't actually change the contents of the string that it's called on. It returns another string. So it creates a new string object, copies across the characters of the current string, making any necessary conversions from uppercase to lowercase in the string that's being returned. So an important feature of strings is that they are immutable. In other words, once we've created a string object, we can't actually change the contents of that string. We can only create new string objects that are maybe different versions of them. Here's another important method. Substring allows us to take a piece of a string and return a copy of that piece. So the API documentation is our key to understanding what functionality exists in any class that we might encounter. And it's going to pay dividends browsing API documentation for classes that we begin to encounter through any programming examples that we might come across. So if we summarize what the documentation provides, it provides us with a description of what we call the class's interface. So it includes the name of the class, a general description of the class, list of the constructors and methods, any return values and parameters of constructors and methods, and a description of the purpose of each constructor and method. What it doesn't include is any detail of the implementation, or rather you might get some description in the class description at the beginning of the documentation, but in general it's not revealing anything about the low-level private elements of a class. So if a class has private fields or private methods, they're not described in the API documentation. So we don't look for those elements in the documentation. We saw that the documentation for the starts with method gives us the method header and a description of what the method basically does, any parameters it takes, and what it's likely to return. And there are a number of methods defined inside the string class that it will be important to become familiar with. And I'm just going to illustrate a couple of those in a moment with version 1 of the project. So methods like contains, ends with is a complement to starts with, equals, so if we want to know whether two strings are exactly identical, then we call equals. Index of allows us to look up a character or another string to see whether that occurs somewhere within a string. Substring allows us to take a piece of a string, and we've got methods like toUpperCase, toLowerCase that allow us to create alternative versions of a particular string. And then trim will remove white space from both ends of a string if it exists. So let's make use of just a couple of these methods in making some adaptations to version 1 of the tech support system, just to make it a little bit more robust in its reading of a user's input and preparing it to be passed on to the responder to start analyzing. So here we're reading the user's input. We're interested in whether that input starts with the word by. And I mentioned in the discussion of the starts with method that as long as the first 3 characters match this, it doesn't matter if anything comes afterwards. And I can illustrate that with this particular example. So if I type by, then that's perfectly fine because the first 3 characters match by, and the starts with method is really not interested in anything that comes afterwards. But it's not terribly robust. If I accidentally typed a space before typing by, I get that sounds interesting, tell me more. So we haven't recognized that the user wants to quit. Similarly, if I happen to type by all in uppercase, again, it's not recognized. I have to type it exactly in lowercase, or at least the first 3 letters in lowercase, for the program to recognize that I wish to quit. So let's make it a little bit more robust. Let's edit this method and start making use of some of those methods that are available within the API description of the string class. So for instance, let's convert whatever we get into purely lowercase. So now if the user happens to type by all in uppercase, we should still be able to recognize that because it's only going to be making comparisons on a lowercase version of whatever was input. Let's also remove any white space that happens to be either at the beginning or the end of the input. So we trim away any white space. And you can read about toLowerCase and trim in the API documentation if you want further details. So having done that, we should then find, if we repeat those examples, I type all in uppercase and that's recognized, fine. I can now put as many spaces as I like before and after the word by, and again the system now recognizes that because it's doing some processing on the user's input that's been read before making the comparison on the input to say, does it start with by? So we've made use of the fact that we've found these methods inside the string class from the API documentation, and we're making use of them to do some filtering on the user's input so that there are fewer cases that we actually need to test when we come to work out whether the user wishes to quit the program or not. So as a review, what we've seen in this video is that Java has an extensive class library. We've really only just scratched the surface. We've looked at one particular class, but now that you know about the API documentation, you can start browsing packages like the java.util package, from which the ArrayList class is taken, the java.lang package, from which the string class is taken, and discover other potentially useful classes, some of which we'll explore in future lectures for this chapter. We've recognized that it's important that a programmer be familiar with the library, and in fact it's to their benefit to be able to make use of classes that other people have already written, because then they don't have to write them all from scratch themselves, and they save themselves an awful lot of time. We've seen that the documentation tells us about the interface of the class, so the methods, the parameters, the return types, and what they do, without going into great detail about how that's provided, without going into detail about the implementation. And we've started to explore classes like string. ArrayList is one that we would want to explore a little bit more further. But it's important, as you begin to explore the API, that you don't worry too much if you don't understand all of the terminology, because it's still early days as far as learning programming, learning object-oriented terminology, and so on. That shouldn't stop you from recognizing names of methods, what parameters they take, and what results they provide. You can still make use of the API even if you don't fully understand everything that the documentation says.